My name is Laurame Macadré. I work as a project manager at WEAMEC. Thank you for joining this webinar on standardization and certification for offshore renewables. This webinar is organized jointly by the OPIN and MEA projects, both funded by Interreg North West Europe. I would like to inform you that the webinar will be recorded. Both the record and the speakers' presentations will be made available on our website in the coming days. So today we will start with a quick introduction on the two organizing projects. I will introduce the Ocean Power Innovation Network, and Daphne Linzel from DMEC will introduce the Marine Energy Alliance project. Then we will hear a presentation on certification schemes for marine renewable energy by Jonathan Boutreau from Bureau Veritas, so on the certification body side. Our next speaker will be Peter Schreigon from DMEC, and he will explain how IC standardization and certification schemes can be applied to your technology. Our last speaker will be Maxime Belorge from Acrocean, and he will provide a useful feedback on floating LIDAR certification. Feel free to ask your questions at any time during the presentations, and we will take them at the end. So please use the chat room for your questions during the webinar. You can see the chat icon at the bottom of your screen. So open it, write your question, and please include in your question the company or name of the speaker that you are writing to. You can also send your questions at the OPIN and MEA project addresses, and we will answer you after the webinar. So I will start with a quick introduction on the OPIN network. I'm a project manager at WEAMEC, so just a couple of words about WEAMEC. We are a cluster, a network dedicated to marine renewable energy in Pays de la Loire, France, with a strong focus on research, innovation, and education. We gather about 100 members, both academics and from the industry. We are funding research projects for our members. We are also active at the European level by participating to working groups and supporting our members to develop collaborative research projects. And we have developed dedicated training courses for offshore renewables. You can find all these activities on our website, so do not hesitate to have a look. One of the projects we are involved in is the Ocean Power Innovation Network, OPIN. So OPIN is a European collaborative network. The network is open to all types of organizations interested in offshore renewables. So they can be SMEs, large companies, research organizations, institutions, etc. OPIN aims to encourage collaborations between different countries and also between different sectors, offshore renewables and more mature sectors such as maritime, oil and gas, etc. So we aim to support more than 100 companies and make the network self-sustainable. The network is funded for 3 years by Interreg North West Europe. Now we are in the middle of this period, which is a good timing to join the network. Joining OPIN is free, very quick, and gives you many opportunities. If you have not joined OPIN yet, you will receive an invitation again after the webinar. So the project is led by SEAI in Ireland, and we are in total 7 partners across Europe working together on a daily basis to develop and animate the OPIN network. The OPIN network gathers about 250 members from 18 different countries all over the world, in Europe and beyond. Some of you have joined the network just before the webinar, so it might not be reflected yet on this chart, but we are very happy to welcome you on board. As you can see on the right chart, there are about 70% of SMEs in the network, but also large companies, academics, institutions, etc. So once you are an OPIN member, how can you benefit from the network? First, you can access free events, like today, for instance. We try to organize one event per month. Next month, in June, there will be a webinar on tidal stream projects. Then in July, a webinar on technical challenges for the wave and tidal sectors. Other events for the rest of the year will be announced soon, but we have already planned a workshop on durability of materials in Belgium in October. You can also benefit from the OPIN network through our technology assessment process, where a SME will get free expert advice on the product or service that is being developed. We can also fund collaborative projects up to 20,000 euros. These are working groups made of OPIN members working together on a common challenge. We will launch collaborative groups on mooring and corrosion in the coming weeks. You are also highly encouraged to contact us if you have a specific challenge related to standards certification that you would like to submit for an OPIN working group. And finally, we can support the trips of Irish and Scottish SMEs attending OPIN events. So please do not hesitate to consult our members directory, our library, and join us on Twitter and LinkedIn. You can also contact us by email if you have any questions. So that's all for me. I can take your questions at the end of the webinar. And now I will give the floor to Daphne for the Marine Energy Alliance project. Daphne, I cannot hear you.
My apologies. I thought I was unmuted by you, but I guess not. So
Go ahead, we can hear you perfectly now.
Great, and we did test this and it worked perfectly. So my apologies to you all. But thanks Laura May for the introduction, and thanks to all of you out there, I understand from all over the world, for attending this webinar today. My name is Daphne Linzel. I'm one of the project managers of the Dutch Marine Energy Center. The Dutch Marine Energy Center is a consultancy agency internationally operating in the marine energy sector. It is our belief that the enormous amount of energy stored in our oceans, seas, and rivers will be a crucial driver to realize global energy transition and foster sustainable growth. With a team of 13 people, and we're still growing, we aim to accelerate the commercialization of marine energy solutions by focusing our activities around the topics of innovation, capital, and policy. Together with partners throughout Europe, we have initiated an international accelerator to advance marine energy technologies and companies from concept to commercial deployment. Through this accelerator, we provide technology and business support, give access to open water test facilities to learn about the potential impacts, and in collaboration with certification bodies, we give support to apply standards and certification to increase the bankability of technologies and build on investor confidence. My colleague Peter Schijgrond will tell you more about that later on in this webinar. With our broad network, we enable developers to get in touch with investors, policymakers, and end users to jointly shape the conditions and accelerate marine energy solutions. And one of the projects we have initiated is the Marine Energy Alliance. The Marine Energy Alliance is a project that is funded by Interreg North West Europe and the 9 partners within the consortium. It is a 4-year project that started in 2018 and runs until May 2022. The objective of MEA is to help progress the combined technical and commercial maturity level of small and medium-sized enterprises and their early stage marine energy technology development, thus to reduce the risk of device failure in the development and demonstration stages to come. To reach this goal, the MEA partners jointly offer a suite of integrated technical and commercial support services that are specifically tailored to the needs of each company that has successfully applied to our project. The 9 partners in the MEA project consortium are located in the Netherlands, France, Ireland, and the UK. And each partner brings in their own technical and commercial expertise in the field of marine energy. Being part of MEA not only gives you access to the knowledge of the partners, but also to their networks. So what have we done, or what do we do? Well, we have had 2 calls for support so far. In call 1, we are giving support to 21 SMEs, and in call 2, another 23 vouchers for support have been sent out. So we are helping over 40 marine energy technology developers progress and de-risk their technologies. We're also cooperating with other marine energy projects to discuss the lessons learned, identify synergies, and share knowledge on certain topics, like this webinar. Together with OPIN, we have started up a series of webinars. Last month, we had a webinar on crowdfunding for the marine energy sector, and more webinars are in the planning. We will keep you informed on this about this on our websites. Another example of how the Marine Energy Alliance cooperates with other marine energy projects is a service we did in the first call. Together with the MET Certified project, we organized a technology qualification workshop on eel energy in Boulogne-sur-Mer. Experts from Lloyd's Register, WEAMEC, DMEC, and of course eel energy work together on this. More information about the technology qualification assessment will be shared with you by Peter. More information on the Marine Energy Alliance can be found on our website and will be shared through our social media channels. Any questions you may have on MEA following this webinar can be sent to mea@dutchmarineenergy.com. And with this, my presentation is ended and I will give the floor back.
Thank you, Daphne. We will now hear the presentation from Jonathan Boutreau from Bureau Veritas.
Thank you, Laura-May. I hope you can hear me well now. Okay,
yes, perfect.
Screen. Okay, so good morning, everybody. So I'm Jonathan Boutreau. I work at Bureau Veritas for more than 10 years, first for the oil and gas industry, and more recently for the marine renewable energies. And I'm offshore wind market leader, and also project manager for a floating project that we are certifying. So my presentation first I will give you an insight of Bureau Veritas. I guess you all know who is Bureau Veritas, what we do, and who we are, but I will give you just some key figures. Then I will come back to the word of standardization and certification, because there are some kind of confusion around these 2 words, which are linked. So maybe it needs a bit more explanations to really understand the context. Then I will give you a few elements about the certification, the purpose and the objectives of the certification. And I will also describe the different certification schemes that exist, because there is not only one scheme, but several depending on many factors that we'll see. And then I will give you more details about the project certification scheme, and I'll give you some technical example of requirements we may have. So first of all, Bureau Veritas. So the historical activity of Bureau Veritas is the classification of ship and offshore oil and gas units. Since then, BV leveraged on this expertise to diversify its activities and its services. And we have basically adapted all the services and competencies to new industries, like, for example, offshore wind or marine renewable energies. So far, the technical competencies for offshore wind and marine renewable energies are located in the head office in France, in Paris. But we also have a network, a worldwide network of inspectors who are specialized in both oil and gas and offshore wind industries, so they can intervene on many projects all around the world. Also in BV, we have made some acquisitions that can also render some services for the marine renewable energies industry, like Matthews Daniel or MAC, that can provide marine warranty survey. So regarding our references, we have experienced several types of projects, offshore wind, fixed or floating, but also wave, tidal, or tech projects for several types of clients, designers, project developers, investors as well. On this slide, it's just a summary to illustrate the diversity of our clients. More recently, we've been involved in several pilot floating wind farms in France, the one in the Provence Grand Large project in Mediterranean Sea, but also the Croix Belle Île project. Regarding wave and tidal, we've worked with Sabella. We've worked also with Naval Energies, Bardo, Chryso. So now we have a good expertise on all these different types of units. And I should also mention the cables. So we have an extensive knowledge of the oil and gas umbilicals and cables. And now we are replicating, in fact, this expertise and adapting it to the offshore floating wind sector. Because we will certify notably the cables, the export cables and Interreg cables for the PGL project, Provence Grand Large floating wind project. So talking about standardization, normalization, and certification. I will not give you much details about that because Peter will describe the IEC Commission, sorry. But just for you to know, talking about marine renewable energies, the main entities that are producing standards and norms are the IEC Commission and ISO. So traditionally, IEC will focus more on electrical systems and ISO on the structure. So for instance, if we consider an offshore wind project, IEC will be applicable to all the turbine and power systems, whereas the structure will be usually designed according to ISO standards. So these groups that are organized by type of units as well. So in IEC, you have the TC88. So this working group will focus on wind energy, whereas the TC114 will focus on other marine renewable energies like wave, tidal, and OTEC, for instance. So these entities will produce norms and standards that will be used by the designers to design the product. And then, as a certification body, we will check that the design is fulfills the requirements defined in some specific documents that will be produced by the certification bodies themselves, or also by the IEC-RE Commission for Renewable Energies. So to summarize, in IEC, they have separated what concerns the design and what concerns the verification of the design according to standards. So that's why you have IEC and IEC-RE. So in BV, as I said before, we will perform certification activity. So basically, a certification is the evaluation of the conformity to standards and norms. So we are not publishing the standards, but we are publishing guidelines that will describe how we should verify that the design is fulfilling some specific requirements. The objective of the certification will be first to de-risk the project and to improve the safety and quality of the project. And usually certification is not mandatory, but it will be required by our national authorities or banks, investors or insurers. So it's not mandatory, but indeed, usually our clients will ask for the certification of their project. As I said before, you don't have only one certification scheme, but several depending on your project and the maturity of your project. Let's start with the approval in principle. Typically, it will apply to a designer which develops a concept. So a concept is sometimes not linked to a project. So at this stage, there are still many uncertainties on some components of the product or on the environment. So typically, a designer or a floater for wind turbine may propose something, but it will have taken some assumptions on the turbine that can be selected for a concrete project, or also on the environment. So the product can be designed typically for the North Sea environment or Mediterranean Sea environment. So it's a choice. And as a certification body, we propose to issue an approval in principle, meaning that we will review globally all the documents pertaining to the project, considering the assumptions made by the designers. So it's kind of pre-certification or a feasibility study. And the first objective will be, once again, to de-risk the project, but also to make sure that there is no showstopper in the design that may prevent further development later on in case of a project. So next certification scheme is a prototype certification. So here it concerns the first device of a new generation. So a prototype, usually it will be installed for a limited period of time, 3 to 5 years. And for that reason, we don't have exactly the same requirements compared to a real commercial project. So in our guide that is mentioned on the slide now, the NY 631, you will find a lot of requirements tailor-made for prototype certification. Then you have the type and component certification. Here we are talking of several components or products that will be designed and manufactured and then used in several projects, different projects. So typically, the blades will be component certified, whereas the turbine, so the RNA of a wind turbine, sorry, will be type certified. It means that the designer will have defined some ranges of conditions, and then the product will be verified considering these limitations. As an example, I can mention if we consider as the RNA of a wind turbine, typically the driving parameter will be the wind speed. So the type certificate will mention clearly the range of wind speed which has been considered for the design and verified by the certification body. And so later on in the case of a real project, we'll just have to make sure that the extreme wind for specific sites does not exceed the wind speed as precise on the type certificate. Last but not least, you have the project certification. So here we will consider a full project. So for example, an energy converter like an offshore wind turbine or a tidal turbine, but also the cables. And it's not only one device, but several installed on the farm. So now we'll deep dive into the project certification. The first objective, once again, will be de-risking the project. And for that, we'll have special care applied on the interface control. Once again, if I mention typical offshore wind projects, you have several stakeholders. So the RNA manufacturer and the designer of the floater and the project developer. Each of them will have some specific scope of work with boundary limits which are clearly defined. But what happens at the interface between the two designers, it can be a concern. As a certification body, we'll make sure that the inputs coming from one designer are considered by the other. So typically, if the designer of a floater is in charge of, I don't know, generating the areas, so the response of the hydrodynamic response to the floater, he will have to inform the turbine manufacturer of the floater response so that it can be considered in the design of the RNA and the tower. And the certification body will also verify all these interfaces. It concerns each module of the certification. I will come back to that. But it's not only the basis of methodology, but also the loads that will be verified by the certification body and the detailed design, meaning that the structural drawings will be also verified. So you can see on this slide the project certification scheme, as you'll find it in the IEC standards or also in the BV rules. So it starts with the site condition assessment. So here, basically, we will review everything related to the geosciences and the environmental conditions, wind, wave, current. That will be, in fact, the data for the next phases. Second is the design basis evaluation. So the design basis, in fact, will list the different technical standards applicable to a project for the wind turbine, the floater, cables, everything. And usually it's split into several documents. You will have the design, what is called design basis part A, which is about site conditions and employer requirements, because sometimes the project developers will have some specific requirements to be considered by the designers. So it will be in the design basis part A. Design basis part B will focus on the RNA and the tower. So typically it refers to the scope of work of the turbine manufacturer. And design basis part C, usually it's for the foundation, floating or fixed. You may have also, it's optional, but design basis part D that will cover the Interreg cables or the substations, if any. So in fact, this scheme will be representing of the project configuration, because you will have usually the designers of the floater which will be in charge of the design basis part C, and also the structure, the support structure design. And you will have the turbine OEM, which will be in charge of the design basis part B, and the wind turbine and RNA design evaluation. That's why you have several modules organized like this. So once we have verified the design basis, so the methodologies that will be used for the design, next phase will be, in fact, to verify the loads, the global loads that will be seen by the device. So for that purpose, usually we will also, as a certification body, build our own independent model, perform some calculations, generate loads, and compare these loads to the loads generated by the designers. Once it's done, we will verify the detailed design, so the structural drawings, basically. And as an input, we will use the loads that has been verified previously, apply them to independent finite element models, and make sure that the strengths and fatigue criteria are fulfilled. So from site condition assessment to support structure or wind turbine arena design evaluation, that's only a desktop job. So we'll perform document review and perform independent analysis. After this step, we will have the manufacturing surveillance, transport installation surveillance, commissioning surveillance. It will mainly consist in inspections at manufacturing places, or during the towing, or during the installation and offshore commissioning. But it will also be supported by some document reviews. So we will review, for instance, the installation procedures and make sure that it complies with the reference standards. Last thing, you have to know that during the project certification, we will also consider the type certificates of the turbine. So typically, for offshore wind projects, the turbines are already type certified. So they come with a type certificate, but this type certificate is not specific to a given project. So the problem that we have now is that for floating wind projects, the floating conditions are not considered within the type certificates. So in case of project certification, we will just make sure that this type certificate remains valid considering the floating conditions. So typically, after the integrated load analysis, we will just make sure that the site-specific loads do not exceed the loads that are specified on the type certificate. So it's recognized, but we have some work to do on this type certificate. So I've described the general context of the project certification. And as I said, in the design basis, the technical standards applied for the design will have to be mentioned. And in BV, we have also produced a technical guide for the classification and certification of floating offshore wind turbines. So that's NI 572, which will give some technical requirements to be fulfilled by the designers. So it was released in, revised, in January 2019. And now it focuses mainly on the design phase, not so much for the moment on the manufacturing and in-service phases. And it will address all the different components of the project. So we'll have some requirements on the material, the design loads, the stability, the structure, scantling, the mooring system. So everything is considered in these guidelines. Just to give you an example, I will give you the example of the corrosion, how it's addressed in these guidelines. So in fact, we have defined a plan for the corrosion protection, which will consider differently the internal and external surfaces, but also it will consider the design life of the structure. When I say design life, it should include also the installation life. So typically, if we say that the design life is 25 years on site, so the corrosion protection should be designed for this specific life. And you'll see that the corrosion deduction, how we will include the corrosion effect in the design, will be also based on this design life. And finally, also the corrosion protection will be adapted to the different zones of the assets, so of the wind turbine in the example which is shown on the slide. So typically for wind turbine, we have defined three main zones for the corrosion: the atmospheric zone, which is always above the waterline. You have the splash zone, which is in fact indeed affected by the intermittent weighting, by the waves. So this is usually where the most corrosion will occur. And then you have the submerged zone, which is always below the waterline. Okay. So then for each of these zones, we'll specify different corrosion protection methods. So first, at the atmospheric zone, we will just ask for a coating. For the splash zone, where I say this is the most sensitive to corrosion, we'll ask for a coating plus corrosion addition. I will come back to the definition of corrosion addition. And finally, for the submerged zone, we'll ask for cathodic protection and eventually coating depending on the type of component. Typically, if the access is difficult for inspection, we may also ask for a coating. So I said that usually we will ask for a corrosion addition. Corrosion addition is in fact a corrosion that you will consider in the design of your structure. So when you will perform your structural calculations, you will have to deduce a thickness which will be representative of the corrosion loss seen by the unit during the full service life. And to calculate it, we give some values in our rules as a guidance, because it can be different if justified by the designers. So what we suggest is to use a corrosion rate of upon 10 millimeter per year. And of course, you will not apply it to the full design life because you will also consider the coating, if any, so you can remove the coating life. Then regarding the cathodic protection, it can be or sacrificial anodes or impressed current system. The trend is more to use impressed current system because, as you may know, the quantity of sacrificial anodes is limited on the site for environmental problems it may induce. So usually if you want to protect your system for the full design life, considering multiple wind turbines or devices, you cannot use sacrificial anodes. So it can be, or you plan to replace your sacrificial anodes, or you can design an impressed current system. Okay, so that's it for my presentation. I will take the questions at the end of the webinar. Thank you.
Thank you, Jonathan. Yes, I remind everyone that you can send your questions at any time during the presentation using the chat room of Zoom. We have already received some of them, so that's great. Please do not forget to include the name of the presenter in your question. So now I will give the floor to Peter Schreigon from DMEC. Peter?
Yes, good morning, everyone. Let me just share the screen. I'm here. Give me 1 second. Yes, welcome everyone. Great to see so many people from all around the world joining this seminar. I'm going to talk about how IEC standards and certification can be applied to your technology. And thank you for the previous speakers who have helped to familiarize you already with some of the terminology. Let me start with the definition for ICRE. ICRE is a 30-party conformity assessment system based on international standards and technical specifications prepared by the IEC, the International Electrotechnical Commission, for equipment used in renewable energy applications. And as the previous speaker already explained, there is a balance between testing and verification and standards. And those standards, so the conformity assessment really demonstrates that specific requirements of equipment or service are fulfilled. So this is a chart showing the IEC Council and how the system operates, and it's supported by the central office in Geneva. It is split out into 3 segments. There's a market strategy board that feeds information on new developments and new innovations that might need support from either standardization or from certification. And then we look at the first tranche, and that's the standardization management board. And under that are the technical committees. And we've seen them already in the previous slides. There's the TC88 for wind. And in our case, what we're looking at for marine energy is organized under the technical committee 114. Those numbers are just sequential. So for example, hydropower is the TC4, and that is already 100 years old, as you can imagine. And then we have the Conformity Assessment Board, the CAB, and they hold the different conformity assessment systems. And one of them is the ICRE for renewable energy. And they are being fed by stakeholders in the market. So external experts, technology developers, test labs, certification bodies, consultants, universities, are all in this group. And I would actually warmly invite anyone who is in this seminar who wants to be involved to send us a message and to guide you on how to become involved in these working groups. So there's specific names for them under the technical committees for the standards. They are called project teams, maintenance teams, and working groups. And under the ICRE system, they're called the special working groups, and then with specific groups for wind, for solar, and marine. And they basically develop the standards that we are using in the market. So the advantages of applying an international system. Well, it's internationally recognized. It is standardized, harmonized, and it provides a transparent set of rules for testing and for reporting. It is based on principles of international consensus through these working groups. It is created by and for the sector. The system allows reciprocal acceptance between test labs and certification bodies all around the world. I'll explain that in a moment in a separate slide. Using an international system will help raise the market exposure for our technology. Basically, working in marine energy, we have a challenge to convince investors and end users that our technologies are reliable and fit for purpose. And by applying the rigor of the IEC system and the standards and using certification, we will raise the market exposure of our technologies and thus help advance our sector. Also, the system will provide new market services for test labs that want to become accredited under the system, or certification bodies that want to be accredited under the system. Of course, we already heard from BV and also Lloyd's Register and DNV. They already provide guidelines on how to apply certification in the market based on the standards that are out there. And the IEC system the ICRE system is basically like an umbrella over all those systems. It will help give an assurance of the technical competence, the integrity and the quality of your development. So let's look at just one of these advantages that I mentioned, which is called the reciprocal acceptance between test labs and certification bodies. We all know that our market is a very international one, and also it requires a lot of time from design to testing to actual getting a manufactured product, and that can take place over different continents during time. And that's why the system is interesting. Let's assume that you're a German company and you're developing a wave energy technology. Then you may want to work with a local DNV, GL, or Bureau Veritas or Lloyd's Register in order to go through what we call technology qualification. The first steps of de-risking your technology, breaking it down into components, and making a very detailed risk assessment. You want to do that in a workshop setting. And after that, you want to do a design assessment. And you want those steps to obtain an official conformity statement so that you can go to your investor and raise capital for the build or for the test phase. The documents that are being created in that step will be valid throughout the whole journey towards achieving, for example, a prototype certificate or a project type certificate, or even a project certificate in the future. The same kind of terms that my colleague mentioned. Now, the next step is you raised your capital and you're going to test, and you got access to a test berth at EMEC. EMEC is an open test facility on Orkney in Scotland, and they're accredited under the system to do power performance testing, power performance assessment of tidal energy converters or wave energy converters. So you test your device there, and they will issue for you a test report under the ICRE system. And again, you will use that as part of your documentation to build up credibility around your technology, to de-risk it, and to raise capital, because you want to borrow money against the lowest rates, and you can reduce rates and internal rates of return by presenting a credible route to market. And so your next step is that you're going to manufacture and sell a project in Japan. And then the manufacturing will take place locally, and it will also be done as an assessment, maybe with a local class NK as a certification body, working under the ICRE system. And maybe this whole process takes a couple of years if you've got some experience in the sector, but all the documents that you build up will all work towards that prototype certificate, or the type certificate, or the project certificate. So let's have a look at what standards have already been developed. This is at the moment the suite of standards, and they're categorized in generic standards, specific ones for wave, for tidal, for rivers, and for OTEC. And what you should note is these codes in the green boxes. You don't have to memorize them, but they will come back later in the presentation. Let's look under the generic ones. Of course, it starts with terminology, then design requirements, there's loads measurements, there's technology qualification, there's a standard on moorings, electrical power quality, and on acoustics. They apply to all the different technologies. Then for wave, there's specific one for performance assessment, the next one for resource assessment, how much energy is actually in the wave, how do you measure that, over what kind of duration, what kind of methods and calculations do you use in order to get a reliable power matrix that you can use in order to do the power performance assessment against. The same goes for the tidal and for the river, performance assessment and resource assessment with those codes. There's a category, the 100 series, the 200 series, and the 300 series. So you see some kind of rhythm there, but don't try to understand the whole logic behind the coding. There are scale testing codes as well, specifically for wave and for tides. I use the word standards and technical specifications mixed In principle, these documents are technical specifications in its first 5 years and growing through at least one edition, one or second edition. And then after 5 years and having been applied in the market, we would consider those technical specifications sufficiently robust to call them a standard. So then these standards are being used as a reference for the verification by the certification bodies or the test labs. And here on the left-hand side, you see the actual certification process, similar in a way to what the previous speaker explained. And those are the steps from technology qualification all the way through manufacturing, testing, in order to get a type certificate. Then in the middle column, you see the documents with the references being used. And again, you see those codes coming back again. You recognize those codes that are being used throughout. And then the actual deliverable issued is in orange on the right-hand side. For the case of the technology qualification, you get a certification plan. It breaks down everything that is required for you to do from the point where you are at when you're doing the technology qualification. It will advise you on perhaps extra testing that you need to do, on how to approach the other steps that are coming ahead. But the other good thing is also to realize that each of these steps in principle you could do separately from each other, and each time obtain a conformity statement with an external consultant or test lab, and then use all those together to build up your documentation for type certificate. And what you see going down the process is the type testing, the performance testing, or the load measurements, the power quality and the acoustics. Those are typical tests that require a test report first under the format of the ICRE, which will explain how to do the tests, what kind of conditions to consider. And then the test report can also be given a conformity statement by a certification body. So now how do we apply this in practice? Well, we have one of our projects. You hear already the MEA and the OPIN. Here's another one. This is called ENCORE, and it stands for Energizing Coastal Regions with Offshore Renewable Energy. So on the left-hand side, you see a few of the steps that we're doing in the project. And then in the middle, you see that we are doing that for 4 different types of technologies. And in the end, on the right-hand side, we're giving feedback to the ISC on how to improve the standards and the certification process. So on the left-hand side, we are going to the steps of technology qualification for a tidal turbine. So that's the -4 we use. Also for a river turbine, for a wave energy converter, and for offshore floating solar. I know that many of these people who are developing the technology and also the partners are in this webinar. So I say hi to you. And then the second one is resource assessment. That's done by Artelia. And you see again those different numbers recurring, the -201 and the 301 and the 101. Then there is design requirements. It's done by Inyanga Marine Projects in the UK. And they're looking both at design and the moorings, and with the help of Bureau Veritas. Then we will do only one set of testing at the University of Ghent, the new coastal offshore basin. And we might refer to the -103 for that. Even though it's floating solar, there's a lot of aspects related to wave energy that could be applied there. And then finally, there will be testing either at EMEC or DMEC or at a third location. And we will build the test reports for the 4 technologies. And then based on all that experience, we will also give feedback for a second or third edition in those project teams or maintenance teams or ad hoc groups, should there be any reason to amend and improve the technical specifications. So our output on the left-hand side is that we're developing these services for those partners that are giving those services. And at the same time, the technologies are delivering pilots in the water, and they're reducing their risks and hopefully raising capital as they go through this process. And the IAC will get feedback and hopefully also get more involvement from experts and from technology developers who are getting involved in those working groups. So as part of MEA, the Marine Energy Alliance project that Daphne introduced, we also work with EEL. That was done and led by our colleague Winston from Lloyd's Register. And he did an excellent technology qualification workshop in Boulogne-sur-Mer. And their feedback was that it was great to have a fresh look from external experts on all parts of their design. There was experts from DMEC and EMEC included as well. It provided them with a very detailed risk assessment. It gave them a much better understanding of the interactions between the subsystems and how that impacts risk assessment. On the other hand, there's some points for improvement. They realized that you really need to have a design freeze. So you have to have a fixed design. And in this case, it would be advised to be at least at a level of TRL 5 or higher. But it is very important that when you start this, that you really have decided on all the main subsystems and that you can judge the risks at component level. Because that was not exactly the case for EEL when we were starting the workshop. There was still some gaps, and that meant also that maybe there was sometimes a too much level of detail requested from the design that could not immediately be answered. Another thing is that the workshop did take a lot of time. I think it was 3 days, and it's a very intense period for a lot of experts together. So we also have to think about, especially in these new times, on how we can maybe do that in different ways. So this is feedback from EEL, and in the meantime, there's also been a similar type of workshop done with SeaTwirl, an offshore vertical axis wind turbine in Sweden. And we're looking for other technologies that would be interested to go through this rigor, either with Bureau Veritas or with Lloyd's Register or DNV in one of these projects or externally. So how do we actually communicate with the IAC? Well, you see all these technical specifications, those project teams, and in those project teams, we have experts that are all part of the consortium in our projects. For example, in the Encore project, we are working with EMEC, Bureau Veritas. As observers, we have IFREMER and DNV and Exeter University. And so in that way, the people that are working in the project are also in those project teams and able to bring that feedback directly in there. So what I started with is that I would like to see or invite people to become more involved in the IAC. It will help you to get access to early market intelligence. It is a network of over 100 experts worldwide in 26 countries. So yeah, in previous times, we would always get together somewhere in the world, and probably in the future, there will be, we look forward to that possibility again, but you hear a lot from each other on what is happening in different continents. It will also help you to focus on your innovation because it gives you a tool set to apply, a common language. And by applying this, you really open up global export for your technology. You reduce risks, you increase confidence in your technology, and thus get access to commercial funding. So this is my presentation. Thank you for your attention, and I give the word back to Laura.
Thank you, Peter. Thanks for your presentation. We got lots of interesting questions in the chat in parallel. We will answer some of them at the end of the webinar. So now I will give the floor to Maxime for the last presentation.
Okay, Laura, do you hear me?
Yes, we can hear you well. Right. We don't see yet your slides.
Yeah, I'm sharing my screen. Just back on the first slide. Screen 2. Now I guess it's good.
Yes, it's perfect. Thank you.
Great. Thank you, Rova, for and thank you to the OPIN network to giving us the opportunity to talk today. My name is Maxime Belorge. I'm project and sales director of Acrocean. I've been working in the maritime and offshore renewable industry since now more than 10 years. And I have spent the last 3 years to set up Acrocean activities in offshore wind industry. Today, I will give you an overview of our floating LIDAR certification process. I just would like to precise some key facts. Jonathan has given us an excellent definition of certification. So certification is a compliance study to norms and standards. And for our application, it's a bit different. So certification is made a strong word, but I will use certification inside the presentation today. But I think you better to understand in certification more a qualification, because we are assessing our system against a roadmap, which is more a guidance than a standard. So that's why certification is a strong word and qualification is a better appropriate word. For my presentation, so I will give you a quick introduction of Acrocean services and current projects, and then some elements of context in offshore wind industry regarding floating LIDAR application. I will introduce the Carbon Trust Offshore Wind Accelerator roadmap and the stage 2 process of certification we have done with our system. Then we'll give you also some description of our technology and results and validity of our certification. And I will also present the stage 3, which is the next step, in fact, of the Carbon Trust roadmap for the floating LIDAR application. Acrocean is a service company, and we provide in-situ ocean environmental data as a service. So our target markets are mainly offshore wind today with our floating LIDAR application. And also we are focused on marine renewable market and also ocean sciences. We set up 3 years ago, and we set up from 2 other French companies, which are CEPS Techno and Valemo. CEPS Techno is a wave energy developer. It's a marine engineering company. They have developed a wave energy system to produce power from waves. And they have also skills in terms of stabilization of floating structures at sea, such as windmills, vessels, and ships. And Valemo is an O&M company, so they have operate and maintaining solar farms or wind farms, and they provide special services to offshore industry. And they also monitor renewable assets from their supervision center in France, and they are also monitoring our floating LIDAR there. So Acrocean integrates and operates a fleet of modular floating platforms that you can see on the screen. And this modular floating platform can host a very large range of sensors to assess the conditions of an offshore site. So we can provide a full service, so from permitting to data delivery, so that makes us a data provider. The 3 services we have developed today, the first for offshore wind assessment, it's a floating LIDAR, so it's a system who assesses the wind condition of an offshore site. We are also developing other services, such as a bird and bats assessment service through a floating 3D radar, so a system able to assess bird activities on an offshore site before any construction on site. And more generally, a full sea observatory station to assess the initial site condition of an offshore site. Our current project, so our first experience was with Meteo France 3 years ago for a 1-year commercial wind resource campaign of Oléron Island in France. We have recently also won a contract, a 4-year master service agreement for Meteo France for measuring the new, for assessing the wind and metocean condition on the new French offshore wind areas. So that will represent around 5 to 6 campaigns in the next 4 years. We have deployed a system, and that will be I will talk about that in my presentation later. For the certification of our system, we have deployed the system close to a met mast in the English channel. We have also performed some tests in Rotterdam, offshore Rotterdam, to check our new systems are compliant with the roadmap. And recently, we have also secured a contract with Energinet, which is in fact the Danish national transmission system operator for electricity and gas. And they are also in charge in Denmark to assess new offshore wind areas as Meteo France in France. And also last year, we have started 2 years wind and metocean campaign in Star of the South offshore wind project in Australia, which is in fact one of the biggest offshore wind development in the world currently. Now, I will introduce some element of context regarding the floating LIDAR market. So there is a big growth of offshore wind developments in the world. So historically in North Europe, but we have new areas with a lot of potential, especially in Asia Pacific and USA. There is a need, of course, for the offshore wind developers and the investors to get very reliable wind datasets, because the wind dataset will be the direct input for the energy yield assessment, and that will help to calculate the return on investments for the life cycle of the project, and directly contribute to the LCOE of the project. And a last element of context, that today there are new techniques, new methods of wind measurements, especially I will talk about LIDAR technology. So the LIDAR technology is a recent technology, and they were replacing met mast onshore, and that's now the case offshore. So, and the challenge for the floating LIDAR, it's, as you can see on the screen, it's to replace the met mast in the offshore met mast by a floating LIDAR technology. So the big challenge is, in fact, to bring confidence to investors in floating LIDAR wind data sets, replacing the trusted met mast measurements. So the met mast is the old and reliable techniques to assess the wind condition. So it's necessary to give give trust, to give confidence to the developers with the new technology of floating LIDARs. So there are benefits, of course, to using floating LIDAR instead of met mast that cost 10 to 50 times less than installing a met mast at sea. So that directly also contributes to the LCOE reduction, and also a lower risk to deploy this kind of floating system. The floating system is very easy to permit, so that allows more visibility on the development schedule, on the development phase of the project. Floating LIDAR has a very low environmental impact comparing to the met mast, which requires a lot of impact assessment to permit the installation of the system. And the system is very easy and quick to install, so we can just use a light vessel in comparison than the met mast. But this new technology has some risk. There is a low experience and low track record in the industry using this technology. And this buoy is more impacted by environmental conditions such as wave, currents, and strong winds, and that we could have an impact on the delivered data sets. So to develop this technology, there was a few years ago. So the first revision of the of the Carbon Trust roadmap was in 2013, and so the Carbon Trust, it's Offshore Wind Accelerator. It's a joint industry project composed with 9 developers, research institute, and offshore wind consultancy companies, and they have redacted some a roadmap, a guide for floating LIDAR to become commercially accepted, and so to be reputed to provide bankable data. So here we have the difference between certification and between qualification, I would say, because there is no existing standards and norms ruling the floating LIDAR certification. There is only a roadmap, so that's why we more employ qualification of the system instead of certification. But we have been told recently that there is an IEC working group open to develop and to publish some works in the coming months for floating LIDAR certification. So of course we will be involved in this work, and I will be pleased to share some interesting information about this working group in the coming months. So regarding the roadmap, because it's the topic of my presentation, regarding the roadmap, there is 3 stages. The one is the baseline. In fact, it is linked to the type of LIDAR unit we use. For accretion, we use a Leosphere wind tube LIDAR unit, and it is automatically reputed stage 1. The stage 2 is the stage we have reached with our certification process. It's the pre-commercial. So it's a validation type of our system. It's a validation of the concept, and it's a proof that our system is able to provide reliable wind data. And yes, it's another difference with certification. It's that our technology, it's not assessed. So the technology, the equipment is not assessed. Only the data sets are assessed, sorry. And that's in the frame of the pre-commercial type validation. So I will describe in the next slide. And there is a third stage, which is commercial. And in fact, it's a significant body of, we have to provide significant body of operational evidence. So we have to multiply the track record and to prove that we provide reliable data sets. So the stage 2 process we have done is the type validation trial of 6 consecutive months against a trusted measurement source, a met mast or a fixed LIDAR. So we have done our deployment against both technology. So the met mast you see on the picture is also equipped with a fixed LIDAR. So we have assessed against the 2 systems. So what is assessed? So one of the key facts assessed is the system availability. So the stage 2 requires that we have to be over 95% of availability during our whole campaign and 90% monthly. Then post-process data availability is also assessed. So we have to be over 85% during all the campaign and 80% monthly. So the data accuracy is also assessed. So it's coefficient of correlation between the floating LIDAR and the met mast. So wind speed and direction are assessed. and we have to be over than 0.97 for the wind speed and 0.95 for the direction. And also there is a sensitiveness study of the system down, and we are assessing the impact of the sea conditions, waves and currents, to the accuracy of our system. So the objective is to provide an envelope and sensitivity coefficient of our trial during the 6 months. And there is an uncertainty assessment also performed according ISC standards. Regarding our test, so we have performed 6 months test in the English channel, as I have already told. The April to October 2019 at the Fécamp Offshore Wind Mast. And here, this is the result we have obtained during this 6 months trial. So we have passed all these KPIs set in the roadmap. So the stage 2 KPIs, but we have also passed the stage 3 KPIs that are recognized as best practices of the industry. But with this trial did not give us access to the stage 3 because we have not proved evidence of deployments, commercial deployment yet. Here, this is the conclusion of DNVGL, who has independently reviewed our 6 months trial. So the conclusion say that our system has formally qualified. So here, this is the difference, qualification and not certification, has formally qualified the stage 2 pre-commercial in the context of the Carbon Trust Offshore Wind Accelerator roadmap. And it is also mentioned that if we change something on our floating LIDAR, the LIDAR unit itself or the floating, it is not considered at the same time. So to confirm our system is valid as a stage 2 for the roadmap, we need to use the same type for our commercial campaigns. Quick fact of our technology, so I will pass very quickly on that. So we use the JEPS techno system, which also provide passive stabilization, so which is good for women with a LIDAR system on our platform. We use a wave energy converter combined with solar power capacity to provide power. We use WindCube LIDAR on the top of our system. And we have a control room with backup power inside using methanol fuel cells and not diesel. And we can combine a lot of other measurements on our platform. So the stage 2 validity, as it was mentioned, as it was stated in the DNVGL conclusion, it's that if we provide new units, we have to be the same type than our WinC2. So WinC2 is the unit we have hired for the stage 2. So that means we use the same float, the same LIDAR unit, and the behavior at sea of our system has to be strictly the same to confirm we have we will deliver the same quality of data. So to confirm that, we have once we have reached the stage 2 validation stage, we have to confirm before each new commercial campaign the new system. So each new LIDAR unit has to be verified onshore, just the LIDAR unit close to a met mast. Then we have to test each new floating LIDAR of same type at sea in the same condition of the stage 2 trial, but on short period, 1 month. But that means that each time we manufacture a new unit, we have to pass the new unit at sea close to a fixed LIDAR during at least 1 month. And there is also a possibility to do post-validation in case of major change during commercial campaign to prove the validation of our system, because sometimes we can have a problem during the campaign. So the commercial campaign is approximately 12 to 24 months. So if you have failure and you have to change any component on the buoy, which could have an impact of the quality of the data, you may have to perform the post-validation in the same condition than the pre-validation to confirm that you are able to provide the same quality of data. So the stage 3, approaching 20 minutes of presentations, and I will pass briefly on that. So just to give you an overview of the stage 3. So the stage 3 is in fact requires higher KPIs, so which are known as best practices. So the system reliability has to be better, and the same for data accuracy. We have to confirm also 6 unit verifications. So verification has to be performed close to a met mass or close to a fixed LIDAR, 3 short and 3 long campaigns, meeting the stage 3 KPIs. And also we have to perform floating LIDAR offshore classification. So that means we need to deploy 2 floating LIDAR units at the same test site during 3 months minimum, and to confirm they are able to provide the same level of quality, data quality. And also we have to test 1 floating LIDAR at 2 different test sites to cover a large range of environmental conditions. And the last requirement for the stage 3 is to confirm 5 commercial project developments where the availability of your system will be assessed during at least 12 months continuous campaign, meeting, of course, the availability KPI of the stage 3 of the roadmap. Thank you for your attention, and open to some questions at the end of the webinar.
Thank you, Maxime. Thanks for your presentation. So now we'll move on to the Q&A session. Thanks for all the questions we have already received so far. Let's start with one we received for you, Maxime. We had a question from David about the LIDARs. How long do you estimate it will take for developers to trust LIDARs enough to replace net masts?
I have still the word, yes. In fact, this is already the case, because floating LIDAR are started by end of around 2010, and during all this the last 10 years we had received 2 versions of the floating LIDAR roadmap, and we see that the offshore wind developer does not systematically deploy offshore met mass, and they considering the level of trust they can have now in the floating LIDAR, and the economical gain to deploy floating LIDAR instead of met mass, that encourage a lot of offshore wind developer to use floating LIDAR technologies to assess the wind condition. And that we see now that there is a very few deployments of met mass, and that of course the floating LIDAR market is growing, so that's a good sign for floating LIDAR.
Okay, thank you for your answer. We will now come back on one question from Bureau Veritas and maybe DMEC. We had a question from Tony Lewis. Jonathan mentioned that ISO standards would be used for structural design, but how does that leave TS 62600-2 from IEC? More generally, also a question about the articulation between ISO and IEC.
Yes, so Jonathan speaking. Maybe I can partially reply to this question. So we have in Bureau Veritas some people participating to both entities, IEC working groups and ISO working groups. So they are, of course, discussing about how to share the work to avoid duplication. So that's something ongoing regarding the structure of floating offshore wind turbines, but more generally, of course, they are discussing. And maybe Peter, you can add on something?
I'm happy with your response. Let's go to the next question.
Okay, thanks.
Okay, we have a question from Catriona Ansel to Maxime. What is the life expectancy of the floating LIDARs? Can it be deployed on several sites?
Yes, they can. They can be deployed on several sites, and we usually the floating LIDAR commercial campaign, as I told you in the presentation, they are a minimum of 12 months to give enough data to the wind developer to assess and to do the energy yield assessment. But it's a minimum, so deployment is more around 24 months to even to 36 months for one deployment. So that means that at the end of this campaign, we demobilize the system from the site, and we of course control all the instrumentations, especially the LIDAR, which need to be back at factory for maintenance, 3 years maintenance. And but we can of course use again the same system for another campaign, and we need to revalidate again the same system close to a met mast with the same process before to go for a new project. And the life expectancy is, yeah, the system, the body of the system is floating is an aluminum float, so it's designed for at least 20 years. And the LIDARs we have seen today, LIDARs still working after 10 years of life. So yeah, we can reuse the systems after, of course, factory control, and after factory maintenance. We can use them again for new campaigns.
Okay, thank you. We now have a question for Bureau Veritas from Agro Visudawan. Do you have any standard physical modeling guideline when doing certification in floating offshore renewables, or all are using numerical modeling? Or more generally, maybe the question about the articulation between numerical modeling and physical tests during the certification process.
Yes, so for sure we will do a lot of numerical modeling, for instance, to verify the loads. But also we may have some, it's not that we impose some physical tests, but it's better to have some physical tests performed in the basin, for instance. And the objective will be, in fact, to extract some physical coefficient, I don't know, typically the damping coefficient, from this test, such as to calibrate some numerical modeling. So it's strongly advised, but not mandatory to perform some physical tests for the certification.
Okay, thank you. We now move on to another question for Acrocean from Eolfi. Are the other measured parameters also compared, certified to reference measurements, such as data well wave buoy, for example?
Yes, they can. So depending how the testing site is equipped, or how equipment type you have also deployed during your testing phase. But yes, the more confidence you will bring with the wind data, of course, but also with the other parameters such as wave, current, THP, etc. More the trust on your system will be high. And so this is not assessed inside the roadmap of Carbon Trust, but that can be assessed separately as existing standards for comparing metocean devices and measurements at sea.
Thank you. We got several questions from Martin Kaiser and from Bodhisakar about the cost of certification. For instance, how much does it cost for a typical prototype certification considering that SMEs have limited funds and much of it is allocated for R&D and product demonstration. So what sort of costs and durations are involved with prototype certification? And in addition, would prototype certification occur during the design phase or after demonstration? Maybe for BV or DMEC, Jonathan or Peter?
Yes, I can take it. So regarding the cost, of course, it depends on many parameters, so it's difficult to answer the question like that, but I'd be happy to have separate discussions to give you a quote. What I can say is that in terms of schedule, we'll try to fit into the designer's schedule, so that to avoid impacting, in fact, the project schedule. So we will work in parallel of the designers, and for that reason, it's much better to be involved as soon as possible, not to wait for that the unit is built or being built before contacting the certification body.
Okay, and another part of the question on the same topic by Martin Kaiser. Are there support schemes that SMEs can apply for to offset the cost of certification and compliance? And on this, I would say that within the MEA and OPIN projects, we offer technical and commercial support services. So there are calls for these services, and they are available for SMEs, and these services can help to prepare the certification work and then reduce the certification costs. Okay, so let's see what other questions we would have. So another question for Maxime on floating LIDAR technology. Aside from wind speed and direction, are there any other wind-related parameters, such as temperature and humidity, which are not recorded? And how incorporating them into the data sets can improve the bankability of the floating LIDAR technology?
Good question. Yes, there is a, as part of independent verification by DNDGL or other third party, they are assessing external parameters at sea. They are assessing mainly current and wave, because they are reputed to be to have the more impact on the quality of the data sets. There is no today sensitiveness study regarding temperature and humidity, but that would be very interesting to record that and to integrate that more deeply in the verification, because if, to check if there is an impact of the quality of the data sets and the bankability.
Thank you. Thank you for all your questions. We will close the webinar very soon. We would like to thank you for your attendance today. If you have any further questions, please do not hesitate to send them to the email addresses you can see on the slide, OPIN and MEA, and we will forward them to the speakers. You will also have the record of this webinar and the presentations uploaded on our website in the coming days. You can also contact directly the speakers if you have further questions. Just to finish, I will copy paste in the chat a link to the satisfaction survey. Please take 2 minutes and give us your feedback. It will really help us and help us to improve even for future webinars. So again, thank you to all and have a nice day.